Hey everybody, Jason here. Today I'm going to be working on an iPhone 6 Plus that was royally fucked over by another technician. Let's start from the beginning. I tried doing an audio IC repair. After repair, it didn't get touch on the far right of the screen. I tried doing it a second time. On the upside, I had forgotten to remove the black exposure from the components. I had to Oh, you floated a bunch of crap. Phone was working. Now it is not booting anymore. It's stuck at 0.18 to 0.03 amps on a DC power supply. Are you able to get this phone turning on again? This PCB arrived with all of its shields removed. We've got the bottom right screw hole thoroughly removed. We have the top shield thoroughly removed. The bottom shield, this guy has removed all of the surrounding metal crap. It looks like we're missing, what here, Q14, is it Q1403 or something is missing on this board? So we've got some scratchy around the screw hole. Can you see this? You might not be able to see this without the microscope. This stuff here has been reworked as the gentleman stated. Let's look at this under the microscope. This looks like ass. Here we are looking at the bottom right screw hole. This actually looks pretty good. I don't see any reason to have removed the screw hole, so that's not, we're not going to worry about that. The chestnut area, I would say, looks pretty good. However, the solder on this side of this cap suggests that this has been floated. Well, yeah, it's definitely been floated. Look, it's actually, the solder on that cap is actually touching this IC here. Did this guy have trouble getting image on the screen? Was it booting at some point and didn't get image? Like, why would we go from... Anyways, the tough part about these prior repair attempt boards, you just don't know. Like, you don't know if somebody's replaced a filter with a cap. You don't know what all has been messed with. Why in the hell is that missing? What the Why is this tore off the board? Dude, there is way more to this story than what this guy let on, right? Okay, let's have a look at the bottom of the board here. Let's look at the TriStar area. So this is somebody who has already replaced TriStar. Tigris is here, but this board is missing Q1403. Are we going to put a new one on there? No way in hell. So, boards that are missing Q1403 typically have larger shorts. People dig in troubleshooting this stuff and they apply power to the battery rail, and the first thing that gets hot is Q1403, so it gets removed from the board. What concerns me more than anything is the missing inductor. Does this thing have an SRAM short? Why is that inductor missing? Right alongside the CPU, this thing was missing L1216. Where did L1216 go and why did it get removed from the board? L1216, for the love of God, PP1V8 SRAM. Let's check PP1V8 SRAM for shorts. So, we have the meter in ohms mode. We're going to put our black probe on ground, and we're going to put our red probe right smack dab on PP1V8 SRAM's ass. And we get, hey, 14,000 ohms, 20,000 ohms. We don't have a short on PP1V8 SRAM. Okay, let's check the other side for a short. I think I can see its little nub there. All right, so we're getting 8 million big ones to ground. So to get this thing to boot, I reckon we're probably going to need to get us an inductor here. This is a liquid damage board, isn't it? Dude, how did you get solder? How did you get solder all the way up here? All right, let's check VCC main for shorts to ground. We have none. We're getting 47,000 big ones, folks. We have no short to ground on VCC main. Well, it seems like we might have some important crap missing here, right? Man, these boards where stuff has been knocked off all over the place, this can be a royal pain in the ass to figure out. What do we got up here? A bunch of caps? Oh, a whole bunch of caps. Somebody just went like knockoff crazy here. All right. What? Why are we messing with NAND? No. All right, we got any shorts here? Got this one really mutilated looking cap that's 800,000 ohms. That's not shorted. We've got 900,000 ohms over there. We got this cap down here that's been messed with. This this is 800,000 ohms. Okay, so we really don't have any We don't have any shorts down here. I think we need to have a good look at its balls. So let's look at the balls on the side of this audio IC. That's actually some decent looking balls. All right, how about on the Mason Touch IC here? The Mason Touch IC also has fabulous looking balls. Well then, does the chip look crooked? Like, where do I even start? It's missing so much stuff. Do I hook power to it? Do I start removing chips off of it because I know this guy has balls bridged all over the place? I think I'm honestly going to start by pulling chips. I mean, what else do I do here? Let's find out what kind of ruckus that we've got going on under this chip and see if we can figure out why this man is no doubt at the mercy of a customer. I don't know, maybe it's his kid's phone and his kid's threatening him or something. Wow, that came off easy. All right, so there's our Mason Touch IC out of the way. While we're at it, let's go ahead and pull this audio codec out of the way. So I'm just going to kind of lift up on the board by the chip and wait for the board to fall out from under it. I'm telling you right now, that all happened way too easy. All right, let's get some flux on the situation here. Not on the audio chip, because I'm not putting that back on, but on the touch chip here. Maybe if this guy's lucky, I'll do a full-blown repair on this board, but man, if I do that, this is somebody that's going to expect me to warranty it, and I'm not about to warranty everything that I see going on here. So, okay. Now we're not going to be worrying about touch just yet. I'm just trying to clean this up while the board's still hot. All right, so let's get a little more goo on here. Yep, M1's hosed, L1's okay. So let's leave that just like it is. Let's get a little closer and have a look at this audio chip. Let's just make sure we don't have anything bridging right now, because remember, primary concern is data. What other kind of mess did I see on here? Oh yes, we have this crap going on here. This looks like hell. We're going to go ahead and remove that from the board. Being very careful not to float the Wi-Fi IC on the other side. Okay, so it wasn't creating any shorts. That would have been okay to leave it there. We have now properly addressed the two components back here that have been screwed with. Oh, geez. I don't like seeing the bubbling of the solder all along the PMIC. Why were you messing with the PMIC? No. Somebody has been dicking with the PMIC. I hope I'm wrong. Do we have solder swelling around the CPU? No, we don't. Okay, so if they have been dicking with the PMIC, they have been daintily dicking with it. Dude, this guy, he's floated every f***ing thing. Like, resoldered the... Like, no. This is what I get for being a YouTuber, letting my audience send me devices. God. Let's go ahead and replace Q1403, okay? Because without Q1403, we can't get power to the board. Q1403, as you can see, has a whole bunch of VCC main and a whole bunch of VBAT. If you look at the schematic, you'll see that Q1403 is basically just a fancy transistor thingy, and we're going to need that to boot. Let's go ahead and replace it. We're going to take us a big old blob of solder on our soldering iron here. I'm using my micro pencil, and we're just going to, just ever so carefully, attach us a blob of solder. There we go. Now to finalize the installation of our brand spanking new Q1403, I'm going to add a baby blob of flux. I'm going to proceed to heat this board up right here at our spot here, until my replacement Q1403 settles nicely onto the board. There we go. Now that we have properly replaced Q1403, I think it's time to go ahead and hook power to this board and see what she draws. Shall we? I'm going to roll the voltage back here. No amount of money is too much money for data, is what this guy said. So let's go ahead and roll the voltage back. I'm going to give it a volt at 1/4 amp. And we're going to go ahead and plug the supply in, and we're going to turn the power supply on. Okay, we're drawing nothing. So now I'm going to go ahead and we're going to roll the voltage up a little bit. 2 volts. It draws no power at 2 volts. No power at 3 volts. Okay, so let's go ahead and set this now to our full 4.1 volts. And it's drawing, what, 10 milliamps? All right, let's give this thing the ability to draw some more current. I'm going to go ahead and roll our current up to 2 amps. We're going to turn the power supply on. And now I'm going to go ahead and prompt this to boot, and I'm going to do this up here at the connector. All right, so at boot prompt, this thing is drawing 40 milliamps, which isn't squat. This thing is not going anywhere at 40 milliamps. We know we're missing this one inductor for PP1V8. So let's see if we can get this cleaned up a little bit. I'm going to add some flux. We're going to take our FM2032 micro pencil, and we're going to, what do they use on this? Like iron? You heard of leaded solder? This guy used iron solder. Jeez, it's like Terminator solder. Stuff didn't melt till like way late. All right, can we get some on that little thing? All right, let's go ahead and get us some wire in here. Ooh, baby. All right, let's see if we can get us a big old blob of solder on here. I'm going to try to cut a bunch of corners here and not use any UV mask to like permanently fix this. I'm not going to attempt to fix this board entirely for this guy. There's just too much. Oh, come on. Ooh. Oh, you can't even see what I'm doing. All right, so I just made this monstrosity of a goofy mess here, and now I'm going to try to sit this inductor down on it. All right, that'll do it, nice and crooked. So we've got the power supply hooked up. We're going to turn the power supply on. We're drawing 0 amps Serenis, and now we're going to use the tweezers. Bring that pin to ground. Oh, 100 milliamps, 120. What's going to happen here, guys? 170. I'm getting 150. See, I'm starting to get excited. I think this is booting. Seriously, why'd you knock? Why was it missing from the board? So this board now looks like it is booting. This thing is going to need touch in order for me to be able to get data. I don't know if we're getting image yet. Should I go for image first? Let's go for image first. Let's see if we're getting image. I'm going to go ahead and hook a screen up to it. Let's hook our power supply up. And let's press the power button and 1, 2, 3, click. 100 milliamps. 180. Apple logo. All right, guys, and we are up to a lock screen. Yay, lock screen. That's not good enough. We pulled the Mason Touch IC off of this board, which maybe I shouldn't have, but in order to get data off of this phone, we're going to need that. Now, to get touch working, we're going to need to address this little Mason Touch IC here. So we're going to need to get M1 out of our way here. I think I may try to go ahead and leave L1 there. Okay. Unless I accidentally disrupt it. Nope, L1's going to be fine. Let's see, this is a data mission. I'm going to go ahead and get rid of this little bastard right here. There we go. I did that because this pad is ground and I just want it out of my way. So let's go ahead and fix our M1 jumper. That is HIFA-B sync and we are going to need that for working touch. We're going to go ahead and tin our wire here. And to do that, I'm going to use my 2032 micro pencil and I'm going to get me a big old blob of leaded on it and just bump the end of that wire and the coating is magically gone. Let's add a little bit of flux to the board there. And let's get our new M1 jumper tacked down here. Get this crap out of the way. It doesn't look too bad. I'm actually going to go ahead, I'm going to leave it exactly like it is, right? I don't need to nitpick this. Now, as you all know, I'm going to need a chip to put on this spot. Nothing would give me greater joy than to use the very same chip that came off of the phone. Let's do that, shall we? Now, I'm going to do a Mason Touch IC reball. We're going to make some nice, beautiful, non-hairy, symmetrical leaded balls. So let's get us a big blob of leaded here. It will be a miracle if this thing boots with touch, lets me unlock the screen, and connects with USB. This one hasn't just been messed with a little bit. This one's been messed with a lot. And may the gods of touch be with us. He said touch. Let's put some nice balls on it, shall we? We'll stick our nice cutout here for the Mason Touch ICs directly over the pads. We're going to squirt out some solder paste here from my beautiful syringe. And we're going to take my beloved plastic blade and fill the holes with solder. Now I'm going to hold the stencil down. And I'm going to use hot air to gradually start warming this up. Man, I miss doing touch ICs all day long every day. I used to whine about it. Now I miss it. It was easy money. All right, so as this comes up to temp, I'm going to switch my hair to the bottom right. And we're going to heat the bottom right and swoop it to the top left. There we go. I could have done that a few thousand times. And there we can get a look at our beautiful, beautiful leaded non-hairy balls. So our board should be ready. Our chip's ready. We're ready to see if we can get touch on this thing, right? So let's put the board back under the microscope. Let's add a tiny bit of fresh flux. And let's start finessing this chip down on here, shall we? Let's get this lined up the best that we can. All right. Let's get this All right, let's get this lined up here the best that we can and start heating it onto the board. Here we go. Okay. It's moved a little bit more than I would like to see, but we should still be okay. Let's go ahead and let this thing do its little... It's going to move itself into place here right about now. So what else are we missing? The audio chip? We're not going to need that, right? Are we missing Q1403? Screw Q1403. Q1403, go home. Please give this man his data so I can eat cheeseburgers. Let's slip this in nice and gently into the housing. Let's hook up the dock flex. And let's go ahead and hook up a screen assembly. Let's hook up our actual power button. Okay guys, here's the moment of truth. Let's go ahead and hook a power supply up to this thing. And we're going to press the prompt to boot. And 1, 2, 3, boot. All right, she is up to a Apple logo. Let's go ahead and let this thing start up and see if we've got working touch. And you know what? While this starts up, I'm realizing this is classic. What is it? No passcode. Okay, so it is up and running. It is at the lock screen. We have assistive touch enabled. You see we've got this little thing we can drag around the screen here. I'm going to go ahead and stop because there's always a chance that a phone can get lost in the mail on the way back to a customer. There's a chance that the customer can get it, this was sent as board only, he can get it back and freaking destroy it and not... This guy's gonna have to give me his passcode. All right, everybody, I'm back with this one. It's been a couple of days, but I have successfully made a backup of this man's PCB. So here's what I think happened with this one. If we zoom in and look at the audio codec that this guy was working on, you will see that pin G11 is PP1V8 SDRAM. So this chip actually does have PP1V8 SDRAM going to it, and right next to it we have ground. So I don't know the full history of the board. Honestly, this looks like a liquid damage board, but this could be caused by the previous tech's flux. I mean, flux can do some really nasty, liquidy damage looking stuff. And also, this board came in without any flux on it. So this could also be some ultrasonic cleaner damage that we're looking at. Perhaps he created a short on PP1V8 SDRAM while messing with the IC. L1216 is largely responsible for creating PP1V8 SDRAM. This is a very, very important inductor. That could explain why the previous tech has ripped L1216 off the board, and could also explain why it sort of feels like they were suspicious of the main PMIC. A short on PP1V8 SDRAM could absolutely cause L1216, the PMIC, and Q1403 to get hot. So that is going to be the end of this video. If you liked the video, please click the thumbs up button. Also, remember, if you're into this type of thing, the tools that I use are always linked in the description below, and I will see you next time. Thanks for watching, everybody. Have a good day. Please just save the data. Money is no object. I only need the data. Before you do this sort of work on phones, if you have the opportunity to make a backup, for the love of God, make a backup. You can make a backup. Please, just make a backup.